Oh, bloody int isn't used. Did it compile? I think it did compile. Successfully, I mean. That would be my callback function. Should be to this DNS resolve. What are we talking about? The DNS resolver. The M timer of that instance. M timer. That would be the DNS resolver. Well, the M timer of DNS resolver was not constructed with a callback, it says. Oh, 266. Well, it was. At least I tried to. Turned out. You have basically, one constructor, the default constructor, and that is using mtimer with I have a lot of those things. Threadpool timer. This one. This sets callback, app callback. should be calling this one. Must have been reset afterwards, I guess. I think it's reset here. So in calling start timer after stopping it again, and that is not allowed because this was reset here maybe. This is stop timer. Next. What? No, this, or where am I? Oh, it's static. Holy big. Yeah, I'm just interested in the timer. Callback. Because this means that it is not set. that is the default constructor. No, it's not really the default constructor actually. Do you think that this was converted to a boolean? That would be so annoying. Debug true. Yeah, probably. It thinks it's funny to call that one. Can we fix that by adding explicit in front of it, or is that something else? Threadable timer constructor. Let's put a breakpoint there. In the meantime, I will add explicit here. That happens before main. Did that work? Nope, did not work. That shall not work. Right. I want to be 100% sure that it is this one. I mean, it has to be, but still. In the case of debug, we also have a boolean here. Let's just pass false. second argument. Now it seemed to work, didn't it? Yup. So even the explicit doesn't work. But this is ridiculous. Let's ask HTTP. Sure, there's other people have asked this before. Nah, the whole explicit is nonsense. Might as well talk about functions and therefore. Yeah, I get that, but hello Sam. Maybe you use a translator or something, because it doesn't really make much sense what you're saying. I post. want to just requires. I don't want to create a callable. Now I can only hope that it works. No, I must see that this works. Of course it doesn't work. Jesus. Expected unqualified ID before opening brace. You added 2 of those. Same amount of errors, so I guess timer still doesn't exist. New types may not be defined in a return type. Perhaps a semicolon is missing after the definition of threadable timer. And also the tape memory initializers. Doesn't even recognize that as a constructor. 287, way down. What the hell is going on? VI. Okay, we clearly messed up here somewhere with whatever I did here. But what did I do and where is it? Nope. I didn't make any change before that. There is still a brace here. Sneaky. I didn't see it at first. So that's the same line then. Nope. We have liftoff. Just don't add too many braces. Well, it seems that ChatGPT did the right thing here. If it runs anyway. And it did, because it works. Although there was an error connection I've used. And again, the DNS is not working. Can't work on that while streaming, because it will probably reveal my IP if I do that. So yeah, let's assume this thing works now. Let's commit it. Status get diff get commit. So it compiles, and then now I have to run some tests. And the very first test did fail a second ago. But now it doesn't fail, it just has the problem with connection reversed. Okay, let's try the next one. Resolver test. What did that do? Found cached entry. There's no output here. No idea what's going on. And no time for it. If it doesn't crash, then I'm going to the next one. While expiring, we have the mutex timer and calling expire locked to prevent destruction while expiring. However, in immediate mode, if there is only a single reference count left, the call to signal 1 will cause a destruct and thus a deadlock. Okay, it seems unsafe to allow destruction here, while this can also be solved by keeping a reference count for each timer. Have a boost intrusive pointer, AI timer M timer with a sufficient long lifetime. Created a usual way with M timer is stateful task creates set interval run. In order to be sure that the object that do something is called on still exists, the destructor of this object must call mTimer abort from its destructor. And in order to be able to call abort, one must have boost intrusive pointer anyway. Or don't use an immediate handler for the timer. Yeah, I wrote this some point in my life. I understood this and I thought that this was enough to make the future me understand it as well. Well, I have a surprise for you, past me. I hardly understand what they're talking about here. Something with a deadlock that might happen, and therefore you have to use it in a certain way, and I didn't. That's kind of literally says it here. So either the default should not be in immediate mode, or we must not be the last one, the last reference. Something like that. I think I have to run this in the debugger and see where it exactly happens. Okay, so we have a timer that calls expired, and apparently the timer expired. It has expired, therefore we call this callback. Yeah, now we're in the thread pool. Yes, it's a different directory. Okay, wait a minute. Now I'm confused. What is this for type then? Oh, boost intrusive pointer. Let's copy that. We should be using that instead of a stupid pointer. And then sign that. And then we call set interval, and then we call run, which seems the normal thing to do. Huh. Set interval, run. After all, it did explain it, I think. If it works now. And it does work, so that was it. Well, I didn't explain the explanation, but I did explain how to solve it. Good example of that you always have to add comments, long comments at every assert. Otherwise, this would have taken me 3 weeks, I think, before I figured out what is wrong. In the case of a deadlock. Worse, I wouldn't have noticed it. And suppose I was working for a company and then, you know, blah, 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 make production code, release it. And then every here and there, people say, sometimes it doesn't work. My machine locks up or the program locks up. And nobody will ever find out why. Ever. Because it happens due to, well, it's a deadlock, so maybe people would find out eventually. Yeah, it hangs, so then you can attach a debugger to it, and thousands of man hours anyway. Not recorded with an assert and explanation. Yes, thank you. What is the next thing then? What do you run? AI timer test. That was the last one. Benchmark. I think this is benchmarking how long it takes to lock a mutex. It takes a while. Let's stop it. It seems to work. Core, whatever that is doing. Core, nothing. Core not found. This is a test. Fibonacci, what is that? Codems, free invalid pointer. Nah. Now a codem here, it's not an invalid pointer. Yeah, nobody knows what it is. Create, yes. Do we even want to try to fix this? And now it runs without any problem at all. of course. That's my punishment for trying to run this, trying to debug this. Try it one more time. Zero errors, okay. And if I run it like this, then it coordinates. I can't say I'm very interested. But I'll look at the code. Race condition maybe. It is using threads. Yep. Nasty. Hello, Mr. Vehicle. Still there? Didn't answer for 9 minutes. Oh, you're still there. Sorry, man. Type it in chat. Oh. Yeah, I didn't say it, but I typed it in the chat now. I started coding in C++ before the standard, before there was a standard. This is a very hard to find problem, I feel, especially because it worked before. So what the hell is different then? I don't think I want to look at it. Let me try to see if there is something else that can be run. Minimal. We have hello world and we have minimal. Can you imagine? And this one prints hello world. That would be minimal, yeah? Mutex benchmark, let's not run that one. Mutex test, just wondering what that does. Nothing. Interesting. Let's run something that is actually doing something difficult. Do I not have that? Unbelievable, so much is just not working. I think this should look up port numbers by string. So restricting the IP protocol to DDP, whatever that is. Echo should return port 4. That cannot have changed. I mean, that's of course still the case. Where is that stored? I have no idea. Somewhere in etc. I can really not remember it. Protocols, of course. Maybe? Yes? No, I'm not sure anymore. Services. Probably services. Blip. Okay, there's protocols. So those are DD something, DDP here. Yeah, there's a DDP. Okay, well at least exists. I think we need to look at etc. services. And port, there's no port 4 at all. Okay, so they cannot return port 4 then. DDP. I was looking at echo. We only have echo for port 7 at the moment. So hardly anything else here. Well, I don't know. That probably fails because they stopped listing it like that. Let's not be bothered by then. Which one was that? Proto test. What the hell is that? Oh, let's look up. 37 is DDP. I remember that one. So that works. And then surf test. Oh, I ran that. That didn't work. Signal test. That's an interesting one. It didn't crash. Oh, probably it worked. Yeah. I hope. Slow down test. I could say that it prints slow down somewhere, but don't see it. No, you full cannot run defer. Okay, I did defer, so it probably works. Resolver, get name info. No need. Oh, I have to give it an IP address. Missing trailing port. Doesn't look like it resolved anything. Again, getting a connection refused or something, or what? Oh yeah, connection refused. I guess my DNS is not working. I think I only connect to localhost and I'm not running a DNS server anymore locally. Already tested that one. Okay, I'm happy. Let's say that it works. Get status. File log task. Get status. Get diff. Oh, and that too. Yeah, there's a better comment. Get status. DNS, get status, get def, get commits. Oh. Oops. Still works. Was the timer test? Still works. Mm-hmm. Mm-hmm. Nah, just commit everything. Now then, I guess we can go back to trying. Where was I? Utils, links viewer utils. Really? Just close it. This is XML. I fixed that already. I forgot what I was doing. Dude, what the hell? Why? Closing everything. Everything. No, this is where we were. Still doesn't compile, of course. I would say const unlock base must be defined before unlock base, because probably this one's derived from that. Now this is the definition of const unlock base. So well, we need a how's it called? for declaration. That's all we need. What the hell would that be inside thread save debug? At least we always need it. Or do we? Yeah, totally we do. Maybe only the unlock base. Use of undefined. Wow, .cxx. All headers go. No capacity. Yeah, I just added that randomly. And as an example of using threadpool, I think. Choose threadpool use. No, what? Somewhere I have this in a comment. Where? Probably that doesn't work. Oh, it does work. Capacity. Nobody's explaining anything to me. What is capacity? I'll have to go to new queue to find out, I suppose. It's even double thing. New queue AI thread pool new queue capacity, comma reserved threads. Oh, this is the size of the queue. Capacity, the capacity of the new queue. Well, it shouldn't be too large, because if we make it large and we need it to be large, then we have a lot of lagging. What is it? Delay. So I think 32 is pretty nice. Definitely don't want to have anything bigger, I think. Oh. Capacity is an int. Let's just make something static. Static static actually. Const expression. No, not static. Why would it be static? Const expression int capacity is 32. My god, it just compiles. Okay, I have no idea what he just did. Well, I mean, I fixed all the bitrot. That's what I did. And therefore we now have a working thread pool. So we created a thread pool and a handler. And then I probably have to pass that handler to the primes object, talking about forcing people to drag in a lot of code. Oh, you want a prime? You want all primes till 100? Dragging my thread pool. Yeah. afraid there's no other way. I'm going to need it. How big is this handle? Oh, it's a handle, so it's probably small. It's a vector index, but it's a wrapper around the size type. It's 8 bytes. You can pass 8 bytes. By value. So I'm going to add an AIQ handle to the primes constructor. So we also have to add it here. Primes, comma, Q handle, which is defined in thread pool AIQ handle, which means that we go here, add that as an include. Probably need much more than that. This is .c. Yeah, well, I don't know. No. That was the header file. So then, just need that definition. It's good enough. It's probably way too much. No, Atkin has a problem. You see, that's what I mean. It's like a virus. This thread pool. You can't even declare it anymore. It must be declared inside main now. Vectorize needs a primes, so that means now I have to pass it all over the place. Might as well add a primes type because, well, it's just a vector, but still. To square free needs the primes now. Square free n comma primes or the other way around. Let's do primes first. And I need this type. Let's pass that as a const reference. Const reference primes, and then we can pass it to vectorization. Or let's also vectorize. I mean, let's also pass it here first as the first argument. Vectorize. And now we have primes. Yay! And that works, and everything works. Except that I don't have a thingy yet. I have to copy that from nth prime to the Atkin 3. Good. So now we have it in primes, ls primes. Wait, fast primes. What? Fast primes. vi fast primes slash primes.h. No, primes.cxx. Yeah, we have a handler. Yeah, you have a handler. Okay, now what am I going to do with the handler? Because now we are here, and now at the moment we are constructing threads over and over and over and over and over, and arbitrary many as well. Like how, and it became so slow. I wonder if this is the because of the creation of the thread. If we join with it, is destructured as well below. Well, I have to learn again, even though I wrote it myself, how to use AI thread pool. Hopefully I wrote some documentation. Yeah, this is where I was. So you do in main, you create a thread pool, and then you have a handler, and then that was everything that goes into main. Let's just read. In order to use the thread pool, one has to create one or more task queues. I think I just did that. Calling new queue. Yeah, so we just did that here. The handle returned by that function can subsequently be used to access the underlying queue and move a standard function bool to return something apparently. Objects into. So we need something that returns a bool, and then I think it just always returning true is okay. Definitely need a lambda. No standard threads. So my lambda must return a bool. How do you do that? Something like that. Hello, this returns a bool. I think. That was let's just make a bare lambda. And then we get to the end of this thing, which is probably you can just execute it here. Ah, so nasty. Do we have a return in the middle? No, I don't think so. Return. No return in the middle. So this is the end then here, and we can just return true. So now I have a lambda, which I execute. That returns a boolean, and I want to see if that compiles. Error, expected body of a lambda expression. That's not how it works. Maybe I did was a bit too enthusiastic with the number of minus signs. Yes, see, that was working. This is working. Okay, we can even run it now, I think. It should go back to the 1.3 seconds. I should time it, otherwise I don't know how long it is. Totally slower. This is unacceptable. Now we are 10% slower than we were. But I didn't even do anything. Is that really just creating a lambda? So if I comment this out, then now I just have to code the way it was without a lambda. Problem is now that I don't have a call. I need this line here. Oops, undo. Let's just put this in its own scope. It would be basically that scope, this scope. Call copy. Yeah, no, not really. No, nobody, absolutely nobody knows why it is. Oh, actually I do. I think I needed a compression of 5 to get that maximum speed for 1 billion. Resource configure make. What is that? Warning, declaration of using fast prime integer that changes the meaning of integer. Oh, that's pretty serious. Well, not really. I think it's just a strange error. It didn't really change anything. Oh, I should not have done that. Git diff primes.h. It's not here. cd prime, cd fast primes, diff primes. Copy that back. No. If it doesn't compile, you just have to delete it. So that, you know, on the make a meme of that. Just on a scale, you see this. You have those memes with a normal distribution, and then you have on this side you see this moron figure, Does it compile? Does it not compile? Delete the lines and then here again. Ha ha. Yeah, now we hope that it will work, right? I don't know how many do I have. Oh, right, yeah. Of course, it's going to work. See? Oh. Whoops. So far, I only have deleted stuff, so I'm still on track. Yeah, see, I'm right. All the way here, all the way on the left, on the right. I mean, what was it testing? The int prime. Yeah, and that should have been times. And we're not back at 1.25. Why? Why? I really don't get this. It's just weird. Cannot think of anything that changed that would have caused this. But yeah, I'll just have to live with the slightly slower version, I guess. I have to edit primes, fast primes, something. Fast primes. So the speed that we were at was 1.34 seconds now. And I definitely want to go to the compression 6. I'll go back to. Now we need to know the speed of that. I think that was slightly slower for 1 billion and faster for a trillion. So it comes on. Make. Configure. Well, that's still 1.34. Did not get slower, it seems. Right. Fast prime slash primes.cxx. And then we're going to introduce this lambda. And it's going to return true. And we're going to execute it. It cannot make any difference, really. It cannot make any difference. I still want to see 1.34. Oh, okay. Let's immediately stop measuring. So now we have a lambda. Now what happens if I create this lambda on the stack? Haha. I had this beautiful word for it. No, I don't know anymore. Something like wipe. Word call or call word. You wipe one column of words. word call. I think that's what I had. So now the wipe call word is my lambda. And then we don't execute this, we just have an assignment and then execute it here. Which obviously should not be any slower. And it isn't. Good, then we have our lambda. So now we go back to the thread pool. And now we ask, how can we execute this in the thread pool? For that we need documentation, of course. Huge code block. Get read access to Q. Oh my god, just copy everything. It's necessary to keep read locked, but not destroying the object returned by, for as long as the write lock on the queue exists. The A and the above code, the lifetime of queue's access must exceed the lifetime of queue access. Okay, try to keep it in mind. Queue's access must be exceed the lifetime of queue access, which is shorter, so that's logical. Lifetime must be longer than the name is longer. And we're going to put that here. Just plot everything. Okay, I don't have the thread pool here, but we can get access to the thread pool also by calling instance on it, or instance AI thread pool instance. That should work. Our instance is loading something. So let's do that just one time at the beginning. The thing wants to be called thread pool, and well, I can do it here, I guess, outside all loops, but still close to what we're doing. Thread pool. That should work. We have a queue handle. Maybe I should call a queue handle then from the beginning. I don't know how it is called. It's called handler. We name it to queue handle. Bool queue full, get producer access to this queue. Queue access is length, queue full is that. If not queue full, place the lambda in the queue. And otherwise, notify one, release, and well, we did what they said that we should do. Except for this thing here. I suppose I could do literally this. Move in. And then put that here. Instead of that is my lambda. We're going to move it in its totality. To inside is moving. That doesn't work, does it? Nope, I don't think that works. There was a thingy in between here. This if. Let's try what happens if we do that. That does work, except for the comment. Yeah, I just want to move this, I guess. I can put it there. That there. Or not. Shift it one more. Move in. Okay, the move in gets the whole lambda. And then this thing here is well, equal to that scope, so might as well remove those. Whew. Now what? This is totally not working because now we are just blasting everything into the queue of the thread pool, which then executes it. Well, maybe it does work. It doesn't really matter in which order it finishes, but we do have to wait for everything to be finished before we continue after this loop. So this loop now must wait here until all the tasks that we just added to the thread pool finished. Which is not easy. I have no clue how to do that, and it's time for me to go to bed. So I'm gonna add a hack here for the moment. I have no idea what it was. Is it not? Is this correct? Boo! I can't remember the syntax. AI thread pool is not defined in the scope. Well, I did remember it. 1 second might not be enough though. Let's sleep for 10 seconds. I don't care how long, but that should definitely be enough for all the threads to finish. Plus, now I want to see all the debug output that comes with the threading. So, stateful task. Do I have stateful? I don't have stateful task. I just have thread pools. Thread pool then. I don't have that anymore. TLS demangler, whatever that is. Broker, we don't have tracker. Maybe we have trackers. AI mutex. I don't know. Just add everything. Timers. Well, we have a thread pool. Maybe we have timers. We notice random pass, but the rest is like Linux viewer stuff. State machine. Yeah, I don't have a state machine, right? So really just thread pool, threads. That's from long ago, maybe. I don't see any other debug channels that I might want to turn on. Thread pool should be enough, and then the rest, well. Why not? Nah. No crash, no crash, still no crash. It's sleeping. 10 seconds. Maybe a bit over 10 seconds. No. Please work. Okay, how long is this going to take? It's going to sleep multiple times 10 seconds. No. I don't know what it's doing, but it's definitely using a lot of CPU. Which is not good, because that means that something is not working. But even then, the main thread, I think the main thread is waiting for that. I think the main thread finished, and then, no, if it's finished, then we should print something. Hello, Shy. I don't know what it's doing. I know not the faintest clue. We have a lot of threads, that's for sure. And they keep running. That's ridiculous, of course, so let's stop it. And then we wonder, what the hell are the threads doing? Info threads. Lots of threads. Yeah, we just have a lot of threads because we have a thread pool. I can restrict the number of threads to something smaller. That's maybe better. Easier to debug also. Yeah, it's totally not clear what it is doing. This one is sleeping. Okay, still sleeping. It should only be sleeping 10 seconds, so I don't... That's weird, I think. And I don't have debug, of course, so I can't debug it at all. That's why we didn't have any debug output. Nothing. They're not doing anything at all. This thread is sleeping, the other threads are not doing anything, if you ask me. Or they are deadlocked, or I don't know what. Inside operator huppeldepup. Well, let's have a look at one of them. There's a thread 4. Switch thread 4. No, it's not a deadlock, it's doing something. No. Looks pretty much like it's never finishing. This is of course the hot loop. So if you run out of here, then we get 389. And then all the threads stop. 14. Thread 8 stopped first. Return true. All the threads stop. Not useful. Seeing the same threads back, thread 4, so repeatedly at this point, and I do a step, and then it should not continue running, should it? Weird things are going on. Scheduler locking step. That works. Thread step. Now we're talking. Thread pull loop. I should have turned this one on to see something. Should have been running out of task by now. They're running the same task. Oh, that's what. I finally caught it. Sorry guys. Yeah. Returning, I was like, that's probably failure or something. So I just returned true. Return true means that the task is not finished. So it just calls the task again and again and again because the task keeps returning true. So I have to return false. And then every time it just starts over from the beginning. So yeah, okay. Primes. Lambda. Return false. We're done. We're totally done. Oh yeah, and what was it called? A debug channel? Something with the loop. I have thread pool and same for stats. No. Oh, the other one is just the pool loop. It's extremely verbose. It's not really interesting, I guess. They're turned off for a reason. I can turn them on when it locks up again. Action and thread pull loop. For now, let's just run it in the debugger. Why not? Not sure what is happening now. It's not using CPU anymore. But it is hanging, it seems. Okay, Control C. Info threads. The bloody main thread is still sleeping. I think it's entering that point very often. So it's sleeping multiple times, 10 seconds. My threads are doing nothing. That's good. Yep. So let's go up to the point where we sleep. Here, and then list that, and then set a breakpoint. 402. Maybe after it. It's a breakpoint at 403. Continue. And then I thought we were done, but we're totally not done because we go to the next mask. Yeah, but oh yeah. Why am I so stupid? Post Bunny, why am I so stupid? Sleeping at the wrong place. We should sleep. We should start all the threads and then sleep. I think I have to sleep after this even. Very confused now. Where is this? Why do I have two loops? Oh, yeah, now I'm getting it. Maybe I was sleeping at the right point, but we do get very often there. We get here once for every prime. Bo's Bunny is funny. Nobody can outshine you, Post. Yeah, actually it was the right place. But we get here once for every prime. So probably sleeping a lot less is better, but I don't know how much. Every prime, right? So that's like very short. How long are those threads running? Or the tasks rather? Blocking is a bad thing to begin with. I don't like it if this thing is going to block on the mutex here. Suddenly I don't like that. So how do I know when all the threads are finished? I'm afraid you can only do that by using a mutex. Or a slowish spin lock maybe. Let's try sleeping less. Milliseconds. 10 milliseconds. It's probably still too much. 1 millisecond. Return the wrong prime, so yeah, it's not working. But it might be that we continued running before one of the threads was finished. It's also possible that now you have multiple threads accessing the same array, which is not atomic. That's undefined behavior to begin with. So we have to change the sieve into a sieve of atomic words. Seriously. But that can't be it. I'm accessing it per column. So unless we continue running too soon, I don't see why this would happen. And this output is not very useful, so maybe I should turn thread pool off. It's not telling me anything. Quit, yes. Let's turn off thread pool. And let's sleep a little bit longer. Like 10 times as long. I should just go to bed, but this is not going to work anytime soon, it feels. Why thread pool still? Oh, it's notice. Why is notice telling me something that flutes? Wake up thread waiting to write to the buffer. I see. I have a queue of 32, and we want to start 90 threads. So it tries to put 90 tasks in the queue, but only 32 fit in. And then it has to wait until one of the threads finishes. But that should only print this. Okay, so we get about... Yeah, and then I can only put one more in. So, oh, so slow. I probably should make my queue larger. Anyway, this is going to be printed like 90 times per prime, so infinitely often. Not a good thing, and also not good that that happens, I suppose. So let's allow. Let's make the queue larger, because it's not funny that that the main thread has to wait. Doesn't make much sense to. In this case, to have a capacity that is so small. If I do 90, then all of the threads should fit in at once. Maybe, yeah, let's see, I don't know. So if now, I would think that if now we see this line, then it starts at the next prime too soon, because, okay, then I didn't sleep long enough. Because it means that the queue is still full, so all 90 tasks are still busy, which means that all the 30 threads are still busy, working on the previous task belonging to the previous prime. And then we already want to add new tasks, which definitely belong to the next prime then. And then now that should not happen. There's one. And another one. So it happens every now and then. And that could fuck things up. Well, it's not that often. Where am I? $41. Nah. We have nine primes. No, wait a minute, that's not true. This is after the generator is finished. So the generator finishes and then we call next prime. It just didn't work. So it took a long time, but it totally didn't work because already. Yeah, okay. I think we can see that much earlier, much sooner, by turning on this. Check primes. So now we check the primes and deceiving while we are doing it. That should assert way sooner. Way sooner. Every thread is crashing now. Well, that's really weird. I'm going to bed. It gets too late. Well, I'm kind of disappointed though. Just not sure how to do fixes. What is going on? Okay, people, thank you for keeping me company, as it were.